Hello, I'm Ed Murphy, and this is Astronomy 1210 Introduction to the Sky and Solar System, Lecture 11, The Phases of the Moon. Now that we've seen in the last two lectures how astronomy enters our everyday lives in terms of our calendar and our timekeeping system, I wanted to talk about the phases of the moon. The phases of the moon are another fascinating topic to teach because it is also a piece of astronomy that we see many days of our lives, but not necessarily every day. I'm sure you've often had that situation of looking up in the sky, either during the nighttime or the daytime, and seeing a moon up there in the sky and wondering why it has that particular shape and why it is in that particular part of the sky. So by the end of today's lecture, you should understand fully why the moon goes through phases and how it is that the phase is related to when and where we see the moon in the sky. But before we get started on the details of what causes the phases of the moon, let's do a little vocabulary. Let's start with just naming the phases of the moon. And I think this is important because you've seen these before. You've almost certainly seen the phases of the moon in elementary school, in middle school. You've probably seen them again in high school. Now I want to not only talk about the names of the phases, but understand why they get these names. So let's go through these very quickly. So we start with the new moon, then we have the waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third or last quarter, waning crescent, new. Now, it's certainly possible to memorize this order of phases of the moon, but I don't think that's the right way to learn it. I think you need to learn the physical model for why the moon goes through its phases. And once you understand why the moon goes through its phases, it's natural that when you're giving one phase, you know what has to come next because you know how the moon is orbiting the Earth. But for now, if you don't remember the phases of the moon, go ahead and spend a minute trying to memorize these, or at least run over them till you're comfortable with them in your head. But for right now, let's take a look at what we mean by all these phases. So here's a diagram that shows the phases of the moon for about 30 days, which is about the length of time that it takes the moon to go through its phases. Technically, it's 29 and a half days for the moon to go through its phases. So we always start the phases of the moon with the new moon. And it's an interesting place to begin the phases of the moon because when the moon is new, we can't actually see it up there in the sky. But for historical purposes, we usually start our discussion of the phases with the new moon. After the new moon comes the waxing crescent moon, and the moon is a waxing crescent for many, many days. The name crescent comes from the fact that it obviously has a crescent shape. And the word waxing comes from the fact that it's getting bigger. And this is an example where understanding where the word waxing comes from will help you remember it. Waxing comes from the old practice of candle making. A long time ago, the way you would make candles is you would take a pot of molten wax and you would take a string, which is obviously going to be the wick of your candle, and you would dip it in the wax and pull it out. Now, what you would end up with is not a fully formed candle. What you would end up with is a string with a little bit of wax on it. But you could dip it again and pull it out, and you'd get a little bit more wax. And dip it again and pull it out, and a bit more. And dip and pull and dip and pull and dip and pull. And every time you pull it out, the candle gets a little bit bigger. So the way you would make candles is to wax them. That is to continually dip them, and they would grow larger. So to wax means to grow bigger. And these are the waxing phases of the moon because the moon is growing larger. So we have the new moon, the waxing crescent, first quarter moon. In a few minutes, we'll talk about why it's called the first quarter moon, even though the moon is half lit up. Astronomers did not do this to confuse you. There's a reason for it, a very good reason I'll point out in a minute. But for right now, just know that that's called the first quarter moon. It's when the moon is exactly half lit up, and this day-night line, called the terminator on the moon, is perfectly straight. After that comes the waxing gibbous phases. Waxing gibbous, waxing because it's getting bigger, and gibbous because of the shape of the moon. We say that this is a gibbous shape. It comes from an old English word that means hunchback. So the first quarter moon had a straight back there, and the gibbous moon has a slightly hunched back to it. And that hunch grows larger and larger and larger and larger until we get to the full moon down here. The full moon is when the moon is fully illuminated, of course, and after that, the phases start reversing. Now we go back to the gibbous phase again, but this time the phase is getting smaller, so we call it a waning crescent moon, a waning crescent. I'm sorry, waning gibbous. This is a waning gibbous moon. So full moon, waning gibbous, That is, it's gibbous shaped, but it's waning to get smaller. To wane means to get smaller. Then we end up with the third or last quarter moon. Either nomenclature's fine. And then we end up with the waning crescent down here. It's crescent shaped again, but now it's waning, getting smaller and smaller and smaller till we end up with the thin waning crescent, and the next day the moon is new and begins its phases all over again. So those are the phases of the moon. And let's go over them real quick again. So we have the new moon, the waxing crescent phases, the first quarter, the waxing gibbous phases, the full moon, the waning gibbous phases, the third or last quarter moon, the waning crescent phases, and then back to the new moon again. Now, another way to tell the waxing from the waning phases, probably the way you were taught in elementary school, especially if you grew up in the northern hemisphere, is that the waxing phases are lit up on the right and the waning phases are lit up on the left. There are various mnemonics for this. The one that I've seen teachers use most often comes from the movie The Karate Kid. Wax on, wax off. Wax on, you start with your right hand. Wax off, you use your left hand. So wax on means that you're adding to the moon. It's growing larger and it's lit up on the right side. And then the wax off means that it's lit up on the left side over there. So that's certainly one way to remember it. I will teach you later on in this lecture a better way to remember it. But know for now that here in the northern hemisphere, the waxing phases are lit up on the right and the waning phases are lit up there on the left. Now, a key part of this lecture is building a physical model to understand why the moon goes through its phases. It's going to be a while before we get there. I want to spend more time analyzing the moon and talking about its phases and how long it takes to go through its phases. But for right now, I want you to answer a quick learning catalytics question. So that learning catalytics question I want you to answer is this. Why does the moon sometimes look like a crescent? Sometimes you'll look up there in the sky and you will see the moon looking like a crescent. I don't want you to do any research. Don't look in the book. I want your gut feeling for the answer to this one. Is it A, the shadow of the earth on the moon creates the crescent shape? Is it B, the moon is closer to the sun than the earth is? Is it C, one part of the moon reflects less light than the other? Or is it D, the earth blocks part of the light that should reach the moon? So go ahead and pick the answer that you think is correct. All right, welcome back. I'm not going to answer this one right now. I'm going to save the answer to this one for a little bit later on. I think you'll be surprised when you see what the answer to this one is as to why the moon looks like a crescent. But in the meantime, let's go back to the moon going through its phases. So the length of time it takes the moon to go through its phases is the synodic period of the moon is 29 and a half days. That is, to go from new moon all the way through its phases and back to new moon again is 29 and a half days. 29 and a half days, it's a little bit longer than 4 weeks. It's about a month long. And as I've alluded to in a previous lecture, that's where the word month comes from. Month, M-O-N-T-H, derives from the word moon, M-O-O-N. And that's because you might remember before Julius Caesar adjusted the lengths of the months typically alternated between 29 and 30, 29, 30, 29 and 30 days. And that's so that in the long term, they averaged out to be 29 and a half days. That is, the month would always begin with a new moon. The full moon would always be 2 weeks later in the middle of the month, and the month would always end with the next new moon. Now, Julius Caesar modified our calendar. He adjusted the lengths of the months. They no longer match up with the phases of the moon, so the month no longer begins with the new moon. But there are still some traditional calendars that uses the phase of the moon as their basis. So I'm not going to do this one as a learning catalytics question. I just want you to think about it for a second. Think if you can think of a traditional calendar that still begins the month with the new moon and ends the month with the next new moon. Were you able to think of one that does that? Off the top of my head, I can think of 3 that do this. One is the Jewish calendar. So the Jewish calendar begins the month with the new moon. The full moon is in the middle of the month, and then the month ends with the next new moon. We mentioned in a previous lecture that this is how the date of Easter got set. The holiday of Passover is in the middle of a Jewish month. And so Easter is defined to be the first Sunday after the first full moon, after the vernal equinox, to make sure that Easter falls after the full moon, which occurs around the time of Passover in the middle of that Jewish month. Another one that follows the phases of the moon is the traditional Chinese calendar. And finally, a third one that I can think of is the Islamic calendar. The Islamic calendar begins the month not with the new moon, but actually with the first sighting of the crescent moon after the new moon. Since you can't see the new moon, it makes sense that you would wait until you could actually see the crescent moon to determine that the new month has begun. So, although this is true for every month in the Islamic calendar, probably the one that's most famous is Ramadan. The holy month of Ramadan begins with the sighting of the crescent after the new moon, and it continues until the crescent is sighted for the next month. So those are three traditional calendars that still use the moon as their basis. So the moon takes 29 and a half days to go through its phases. This is called the synodic period of the moon. Interestingly, this is not the length of time it takes the moon to orbit the Earth. Because the moon takes almost a month to orbit the Earth, we have to account for the fact that the Earth is also moving in this time. And like the difference between a solar day and a sidereal day, there's a difference between a synodic month, which is the length of time it takes the moon to go through its phases, and a sidereal month, the length of time it takes the moon to turn, to orbit the Earth, to orbit the Earth with respect to the stars. Here's a really nice animation that shows us the difference between these two. So let me bring this animation up so that you can see it. So this shows the difference between sidereal and synodic months. So remember, a sidereal month is with respect to the stars, and a synodic month is with respect to the phases of the moon. All right. So there's the sun over there on the right-hand side. Here's the Earth orbiting the sun. There's the moon orbiting the Earth. We have a new moon right now because the Earth, the moon, and the sun line up. So that is a new moon. One orbit later, that is one sidereal month later, the moon has orbited the Earth one time. It's gone a full 360 degrees around, but you'll notice it's not a new moon yet. It has to spend an extra 2 days, little more than 2 days, in order to get back to being the next new moon. And that's the synodic month. So the sidereal month, the length of time it takes the moon to orbit the Earth is 27.3 days. The synodic month to go through its phases is 29 and a half days. So here we go again. There's the new moon. One sidereal period later, 27.3 days later, the moon has returned back to that position. It's completed one orbit, but it has not gone through its phases. It has to go an extra 2.2 days, 29 and a half days total, to be back to the new moon again. And that is the difference between the synodic and the sidereal moon phase a month. Okay, so back to our slides. So the time it takes the moon to orbit the Earth with respect to the stars is the sidereal period. It's 27.3 days. Another thing to know about the moon, I'm just laying it out here, we're going to talk a lot more about this when we get to eclipses later on, is that the moon's orbit does not lie in the ecliptic plane. That is, it's not the same as the Earth's orbit around the sun. It's actually tilted by about 5 degrees. And we're going to use that piece of information later on in the course to talk about why we do not get lunar and solar eclipses at every full and new moon. That is, every time the moon is full, it doesn't pass into the shadow of the Earth. And every time the moon is new, it does not create a solar eclipse. And that's because the moon's orbit is tilted. We'll see that later on. But let's go back to talking about the phases of the moon here for a few minutes. It takes 29 and a half days to go through its phases, which means it's a little bit more than 4 weeks. So to go from new to first quarter takes about a week. To go from first quarter to full takes a little bit more than a week. To go from full to third quarter takes a little bit more than a week. And to go from third quarter back to new again takes a little bit more than a week. So it takes a week for the moon to go through each of these 4 parts of its phases. Now, one thing to know, by tradition, we say that the moon is new, and we say that the moon is new on one particular day. The thing is, in truth, the moon is new in one particular moment. The moment that the moon passes between the earth and the sun, it is the new moon. But it is only the new moon for an instantaneous second. That second, as soon as it passes between the earth and the sun. A little bit before that moment in time, it's a waning crescent, and a little bit after that moment in time, it's a waxing crescent. However, for traditional purposes, we say on the calendar that it is new for that whole day. And then the moon is a waxing crescent for about 7 days. And then we reach the first quarter moon. The moon is a first quarter moon for 1 day. Again, it's really just instantaneous. And it's instantaneous when the earth, the moon, and the sun make a 90-degree angle with one another. And because of that 90-degree angle, this terminator line, this day-night line on the moon is perfectly straight. But for calendar purposes, we say that the moon is first quarter for the day. So typically you'll see printed on the calendar it is first quarter, and we just say that it is first quarter for the whole day. But then for a little bit less than a week, it is waxing gibbous. And then we reach the full moon. And again, we've seen this before, the moon is full for an instant in time when it is opposite the sun in the sky. But nevertheless, we traditionally say that it is full for the whole day. Then it is a waning gibbous for about a week, third quarter for a day, waning crescent for a week, and then back to new. So each one of these phases takes about a week. So it's a week from new to first quarter, a week from first quarter to full, a week from full to third quarter, and about a week from third quarter to new again. That is where first quarter and third quarter come from. So the moon takes about 4 weeks to go through its phases. After 1 week, we've completed 1/4 of the phases of the moon. And that's why we call it a first quarter moon. It means that the moon is not a quarter full, has nothing to do with how the moon appears in the sky. It has to do with the fact that the moon is 1/4 of the way through its phases. Another quarter goes by and we get the full moon. I suppose another name you could call the full moon would be the second quarter moon, but we never do that. We always just call it the full moon. And then finally, after 3 weeks, we are 3/4 of the way through the phases, and that's why this one is called the third quarter moon. And then finally, another week goes by and we start the next phases with the new moon. So that is why we have the first and third quarter names. The last thing I want to mention about the moon is, as I said, the full moon, it's truly full for just an instant. But for traditional calendar purposes, we say that it is full on a day. But here's the thing. Unless you watch the moon regularly, unless you've taken a good close look at the moon, you're probably going to call the moon full for at least 4 or 5 days. And in fact, even though here I can distinctly see that there's a shadow on that side, and even to me, this one looks like it has a little bit of a shadow right there, a lot of people won't see that, and they might call the moon full for a week. But it's really important to know that the moon is full for an instant, or possibly you could call it a day, but no more than that. The moon is not full for 5 or 6 days. This is going to become important later on when we talk about the effects of the full moon. All right. The last thing I want to mention about the phases of the moon is, now that you know that it takes the moon about 29.5 days, or we could call it 30 days, you should be able to calculate what the phase of the moon is any time in the past or future, given the phases on a particular day. So for example, imagine that I tell you that the moon is new today. Or let's imagine that the moon is new today. And then I ask you, what is the phase of the moon 1 week from now? Well, if the moon is new today, 1 week from now, it's going to be a first quarter moon. If I say the moon is new, whoops, I'll come back to that in a second. If I say the moon is new today, what's the phase of the moon going to be in 24 days? You would say to yourself, okay, if it's new today, 24 days is 3 weeks, which is 21 days, and then a couple days beyond that. So 3 weeks, if it's new today, 1 week, 2 weeks, 3 weeks, and a couple days. So if I say the moon is new today, what's the phase in 24 days? It's going to be a waning crescent moon. So I want you to put this to practice right now. Go ahead and pause the video and answer this question. The moon was new on Sunday, June 21st. What will the phase of the moon be on July 31st? So figure out how many days go by between June 21st and July 31st and figure out what the phase of the moon will be. And if you need to add up, remember how to remember whether June has 30 days or 31 days. Use your knuckles January, February, March, April, May, June. June falls between the knuckles right there. If you don't remember what that means, go back and watch lecture 9. I think it was that I covered that. But or you can look up the number of days in June. So figure it out. What's the phase of the moon going to be on July 31st? All right, let's answer this question. So how many days went by between June 21st and July 31st? So the first thing we know is we're starting on June 21st, and June falls on that space between the knuckles, which means that June has 30 days. So we have the 21st. So the number of days that go by to July 31st, we have the 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th. So we have 9 days in June. And then obviously we have 31 days in July. So about 40 days go by. Now the moon takes 29 and a half, 30 days to go through its phases. So 40 days means it's going to be one full cycle of its phases, 30 days. So it's going to go from new to new again, and then 10 days beyond that. Well, what's 10 days beyond the new moon? 7 days is the first quarter moon, and 3 days beyond that means that the moon is going to be a waxing gibbous moon. So the right answer to this one is a waxing gibbous moon. If the moon is new on June 21st, 40 days later on July 31st, it will be waxing gibbous. Okay. You should be able to do that given the phase of the moon on any day. You should be able to roughly calculate what it will be. I think a really fun thing to do is figure out what the phase of the moon is going to be on your birthday. So look at the June 21st, knowing that the moon is new on June 21st. Think about when your birthday was this year, or think about when it's going to be this year, and see if you can figure out what the phase of the moon is going to be on the day of your birthday. Okay, let's move on with the phases of the moon. A really important thing about the phases of the moon, because it kind of goes to building a physical model as to what causes the phases, is to make sure that you get the shape of the moon correct if you're ever asked to draw it. If you look at how the moon appears when it is a waxing crescent moon, it's important to notice that the horns of the crescent do not go beyond the halfway mark. In fact, the horns of the crescent meet at the halfway mark. That is, if I draw a line that connects the north pole of the moon and the south pole of the moon right here, those horns should go to those poles but not go any further. And that's contrary to how many people draw the phases of the moon. So you will often see people drawing a waxing crescent moon right here with the horns, this horn right here and that horn right here, going well beyond the halfway mark. You'll see this in lots of symbolism around the world. And it's just to point out that is not what the moon looks like. The horns on the moon never go beyond the halfway mark. At best, they go right up to the halfway mark. So just keep that in mind. It's a bit of a pet peeve of mine. Make sure that you draw the moon correctly. And the reason for that, and I think this is why I'm bringing it up and why it's important, is to have a physical understanding of what causes the phases of the moons. This produces a misconception about what causes the phases, and we'll get to that a little bit later on. All right, let's talk about the moon on the calendar. So because our calendar now alternates between 30 and 31 days, right? Our months are 30, 31, 30, 31. The month averages out to be 30 and a half days. The phases of the moon are 29 and a half days, which means every month is a day longer than the phases of the moon, which means the phases of the moon march through our calendar. They get about a day earlier every month. So here are two lunar calendars for 2014 and 2015 laid side by side. And if we look here in March, this is 2014, 2015. I'll show you 2020 here in a second. But here's the new moon. And then a month later, it's about a day earlier and a day earlier and a day earlier. And it gets about a day earlier. Sometimes it doesn't get a day earlier. That all depends on the timing exactly. And then at the beginning of the year, it gets messed up because February is always short a couple days right there. So it gets a day earlier, but then it jumps down, but then it gets a day earlier like that. So the moon's phases are typically marching through our calendar. That is, as the year goes on, the new moons are getting earlier and earlier in the month, every month throughout the year. A common thing that you'll often hear discussed is a blue moon. A blue moon is today defined as a time when we have 2 full moons in a month. And in particular, the blue moon is the second full moon in a month. So in this particular case, I want you to notice that July of 2015 had a blue moon. That is, the moon was full on July 2nd, and 29 and a half days later, the moon was full again on July 31st. And we call this second full moon a blue moon because it only happens once every couple years. You'll notice that in 2014, there were no blue moons. In fact, in order to get a blue moon, the new moon has to be occurring right in the middle of the month. If you have the new moon right in the middle of the month and you have enough days in the month, you can get 2 full moons in the month. You'll notice June didn't have quite enough days. June had a full moon on the 2nd, but 29 and a half days later, it only had 30 days in the month, and because that was on the 2nd, the full moon had wrapped over here. Obviously, February can never have 2 full moons in February because it takes 29 and a half days for the moon to go through its phases, and February is only at its most 29 days long. So you can never fit 2 full moons in February. It can never have a blue moon. So I just wanted to point out that blue moon in July 2015. Here's the calendar for 2020. So you will notice that in June of 2020 right here, we've got the new moon occurring on the 21st. It's a day earlier in July on the 20th, a day earlier in August, a couple days earlier in September, a day earlier in October, November, December. You will notice that in October, the new moon is occurring right in the middle of the month. And sure enough, in October, we have a blue moon this year. So there's a full moon on October the 1st and another full moon on Halloween night, October 31st. So we will have a blue moon on Halloween, so this year. Okay. Now that we've talked a lot about watching the moon go through its phases, let's try and build a physical model that describes why the moon goes through its phases. So we're going to start with that with a physical model of the Earth-Moon system. Now, we've seen this already in the second lecture where I gave you a tour of the universe. A couple just numbers here. Don't worry about memorizing the numbers, but I just wanted to point them out. The average distance from the moon to the Earth is 384,400 kilometers. However, the moon's orbit around the Earth is elliptical, and sometimes it's a little closer than average, sometimes it's a little farther than average. Its closest approach is 356,000 kilometers. Its farthest approach, or its farthest distance, is 406,000 kilometers. You can see, given that the average distance is 384, that its closest and farthest approaches aren't that much different from one another. When it's at its closest, it's not that much closer than average, and when it's at its farthest, it's not that much farther than average. Ultimately, though, this number, 384,400, is 30 times the diameter of the Earth. So you'll remember when we were doing the scale model solar system, I used my globe of the Earth. And I said my globe, which was 1 foot across, the scale model moon is 1/4 the diameter of the Earth. So that's a scale model of the Earth moon together. But this model moon should be 30 Earth diameters. Or, since that globe is 1 foot across, 30 feet away in this model. And with my camera, of course, I can't get the moon 30 feet away, but that is the scale model of the Earth-Moon system. There is a diagram showing you a scale model of the Earth-Moon system. So that is the Earth and the moon to their proper sizes and to their proper distance. All right. The diameter of the moon is 27% the diameter of the Earth, so it's about 1/4 the diameter of the Earth. And these other two numbers I'm just going to list for interest. It's about 1/81st the mass of the Earth, so it's 81 times less massive than the Earth, and its volume is a little bit less than 50 times less than the volume of the Earth. Okay. We've also seen this picture before, this picture that shows us the moon and the Earth to their proper sizes. So this was a photograph you'll remember taken by the Galileo spacecraft as it headed away from the Earth-Moon system out to the outer solar system where it spent many years investigating Jupiter. Actually, when it took this picture, it was actually headed to the inner solar system because we didn't have a booster big enough to send it out to Jupiter. So it had to go to the inner solar system and gain a little bit of energy that way before it went to the outer solar system. But nevertheless, as it was leaving, it took this picture, and that is the scale size of the moon compared to the Earth. So you can see South America right here, and you can see that the moon is about the same size as the northern half of South America. It also shows you the correct color of the moon compared to the Earth. The moon is actually remarkably dark. The maria, or the seas on the moon, are as black as charcoal, and these other areas are a very dark, dingy gray. And you wouldn't know that because normally when you look at the moon, you're comparing it to the blackness of the sky, and the moon looks quite white, quite bright compared to the blackness of the sky. But if you were to hold up a giant piece of paper you would notice that the moon is, especially if you do this during the daytime when the sun is out and you can see the moon in the sky, you will notice that compared to a white piece of paper, the moon is a dingy gray color. And that comes from the composition of the rocks. We'll find out more about that later on. But the moon shines by reflected sunlight. It's not giving off any sunlight of its own, any light of its own. It just shines by reflected sunlight. And on average, it reflects about 7% of the incident sunlight that's hitting it. And as we're going to see here in a minute, the phases of the moon are the result of varying viewing angles throughout the month. That probably doesn't make any sense to you, nor should it. I just wanted to lay that out there right now. That's the sort of the one quick definition of the phases of the moon. So let's go ahead and break away from the lecture slides for a minute and let's look at stellarium. Because what I think we're going to do in stellarium here is we're going to walk the moon through its phases for a whole month. All right. So the first thing I'm going to do is I'm just going to use the page up and page down buttons here to scan out a little bit so that I can see the whole sky. Now, I'm going to tell you what we're going to do in stellarium now is something that you should do at some point during your life. At some point during your life, you should spend a month watching the moon go through its phases. I think this month is a great month to do this, and I think you should go ahead and start now and watch the moon go through its phases. It doesn't take much time. Just every night, go out for a few minutes, look at the moon, come out the next night, look at the moon, come out the next night, look at the moon. And the two things I want you to look for are how the shape is changing and where the moon is in the sky relative to the sun. So let's go ahead and do an example of this. We said that the moon is going to be new on, or was new on June 21st. So let's go to June 21st and let's set our time here for sunset. So let's see, let's go a little bit further back here. There we go, there's the sun. So let's set it right around the time of sunset. That looks good right there. Maybe go just a couple more minutes and then we'll pause it. All right. So this is 9 o'clock in the evening on June 21st. First of all, notice where the sun is. The sun is setting down over here in the west. So that's where the sun is right now. Now the moon was new on the 21st, so I wouldn't expect to see it. So on the 22nd, the moon is still fairly close to the sun, so I wouldn't expect to see it. But here's the moon on the 23rd, and there it is. So look at the moon up there in the sky. Now, we know, or well, let me ask you this. In your head, what's the phase of the moon right now? I'm hoping you answered that it was waxing crescent because the moon, this is the 23rd, the moon was new on the 21st, and so on the 23rd, the moon is a waxing crescent. Here's the moon on the 24th. Whoops, here's the moon on the 24th, the 25th, the 26th, the 27th, the 28th. Notice that I'm doing this every night at 9 o'clock. When you go out to watch the phases of the moon, try and get out every night at the same time. Try and go out, say 9 o'clock every night. And what you're going to notice is that night after night, the moon is moving through the sky. And what you're seeing actually is the moon orbiting the Earth. That is literally the moon orbiting around the Earth. You can see it moves a little bit every night. It does 360 degrees, and it does those 360 degrees in about 30 days, right? The phases of the moon are about 30 days, 360 degrees through the sky. So that means the moon moves about 360 divided by 30, about 12 degrees per day. So a little bit bigger than the width of your fist out at arm's length is how much the moon moves every day as it orbits the Earth. So the two things I said I wanted you to watch is the relationship, is the changing shape of the phase of the moon and its relation to the sun. So let's do something here. Let's go back to the 23rd. So let's go back to June 23rd and let's look at the shape of the moon. Now, to see the shape of the moon, we're going to have to zoom in on it. So I'm going to click on the moon right here. And then I'm going to come down here to this little bar at the bottom. And I'm going to say, I want you to center up on the moon and keep the moon centered. Now, the moon looks full there, but that's only because it is actually so small in our sky that they can't show us the phase. To see the phase, we're going to have to zoom in. And to zoom in like this on a Windows machine, I'm using the page up and page down button, or you can use the scroll wheel on your mouse. But if you're on a Mac, but there's the moon up there in the sky, and you'll notice it's lit up on the right, and so it is a thin waxing crescent moon. So there it is on the 23rd. The 24th, it's a little bit bigger. The 25th, the 26th, the 27th, the 28th. Oh, and remember the 27th, it was a first quarter moon there. So that's first quarter. Waxing gibbous now, 28th, 29th, 30th, 31st. Oh, sorry, there's no 31st in June. July 1st, 2nd, July 3rd, July 4th, July 5th. Okay, so that's the moon going through its phases. You saw that night after night, it was growing larger and larger. One of the nice things about Stellarium there is I can just click the down arrow and go backwards in time. So the moon, as the days go on, it is waxing. It is getting bigger and bigger and bigger and bigger and bigger and bigger in our evening sky. That's the first thing I want you to notice. Now I want you to notice the relationship with respect to the sun. So let's go back to the 23rd. Okay, remember the 23rd, it was this thin waxing crescent moon. Now I'm going to use the page down button or the scroll wheel to scroll out, zoom out. I'm going to set this here so we're facing sort of towards the south right there. Maybe zoom them in a little bit more. There we go. All right, now let's look at the relationship between the moon and the sun. Remember, today the moon is a thin, well, the 23rd, the moon is a thin waxing crescent. On the 24th, it was a little bit wider, but it's also a little bit further away from the sun. And on the 25th, it's a little bit further away from the sun and a little bit wider. And on the 26th, it gets wider still. And the 27th, there was our first quarter moon, and it's even further from the sun. And every day, as the moon gets bigger and bigger and bigger and bigger, it's getting farther and farther from the sun in the sky. Until an amazing thing happens this month. The full moon is going to rise at the exact moment of sunset. So you'll notice the full moon is over here just rising up and the sun has just set over there. So we're going to end up with this spectacular thing to view in the skies where the sun is setting on one side of the sky and the full moon is rising on the other side of the sky. We'll see here in a few minutes how often that happens. All right, so that is the full moon rising as the sun is setting. Now, if we continue this to the 5th, 6th, 7th, you'll notice that the moon is gone. And that's because in order to see it, now we're going to have to switch over to the morning hours. Now the moon, it doesn't rise until later in the evening, and it's not visible until the morning hours. So what we can do is going back to the 5th right here, we can change from sunset, we can change over to sunrise right there, okay? So there is sunrise. So we see the sun over here in the early morning sky over here in the northeast. So what we see on the 6th, let me ask you to predict. So I'm going to look at the shape of the moon. What's the moon going to do over the next couple of days? So let me zoom in on the moon here. Let me lock the moon so that it's not going to move. And let me zoom in on it here. So here we are on July 6th. It's almost full. What's the moon going to do for the next couple of days in terms of the shape of the moon? So I want you to make a prediction in your head. All right, let's see what happens. So here's July 7th, 8th, 9th, 10th. We're obviously in the waning phases. It's getting smaller. It's waning gibbous, and that's almost the first quarter right there. That's a little past the first quarter, so this is a waning crescent, and then it gets smaller and smaller and smaller until July 20th when we end up with the next new moon. And what I wanted you to notice as we do this is, let me zoom back out here to July 5th or July 6th right there. As I zoom out and look at the position of the moon with respect to the sun, I want you to notice how it gets closer to the sun. So day by day, as the moon is getting smaller, it is getting closer and closer to the sun. It's going to have a beautiful meet up there with Venus on July the 17th in the morning sky. And then we end up with the new moon on the 20th. To understand what causes the phases of the moon, we have to keep these two things in mind. The phase changes day by day, but the change in phase is related to how close the moon is to the sun in the sky. So let's go back to our PowerPoint slides here. Oh, let me just exit out. Oh, there we go. Okay, so let's go ahead and pick up with the physical model for what causes the phases of the moon. So this is just a summary of what we just saw in Stellarium, which I like doing a little bit better than this graphic. But if we go out at the same time at sunset every night, day after day, the moon is moving through the sky. So here's where it is on the 23rd, the 24th, the 25th, the 26th, moving on. Well, it's actually probably, that was the 27th right there. So day after day, the moon is moving through the sky, and it's getting, as it gets further and further from the sun, it's getting larger and larger and larger until we reach the morning sky, when we start with the full moon. And in the morning sky, it's waning. It's getting smaller and smaller and smaller as it gets closer and closer to the sun. So we want to understand why the moon goes through its phases, and there are two ways to do this. The first one is we can actually use a diagram like this to look at the phases of the moon. And the second one is to build a physical model. And we're going to do both of those. Let's start with this diagram first. An absolutely key part to understanding why the moon goes through phases is understanding that the moon is always half full. Notice that here the moon is lit up by the sun. The sun is lighting up half the moon of the moon is in shadow. Over here, how much of the moon is lit up? Go ahead, I want you to say it out loud. It's half lit up. Say it. It's half lit up. How much of the moon is lit here? It's half lit up. It's half lit. How much of the moon is lit up here? It's half lit up. Everywhere as the moon goes through its phases, let me phrase it differently. The moon is always half lit up, and that may be the key thing to understanding the phases of the moon. The moon is never less than half lit up. It's never more than half lit up. It is always half lit up. But why the moon goes through phases is we don't always get to see the side that's lit up. Think about the new moon right here. During the new moon, for an observer standing on the earth, when they look up at the moon, the lit side of the moon is facing away from them. The unlit side of the moon is facing towards them. So when they look up there in the sky, they see a new moon. They see a new moon, not because the moon isn't lit up. It's because the lit side is facing away from them. And then a couple days later, when they have a waxing crescent moon, remember the person on the earth can only see the half of the moon facing towards them. And the half of the moon facing towards them is mostly dark with a little sliver of light over there on the right-hand side. They see the waxing crescent moon. Now, what's important during the waxing crescent moon is the moon is half lit up. It's just that where it's located, most of the lit side is facing away from us. Only a little bit of the lit side is visible. Now at the first quarter moon here, remember we can only see the half of the moon that's facing towards us. We can only see this bottom half of the moon. And when we look at the moon, it's half lit up, but it also appears half lit up because we see it half lit and half dark. And then during the waxing gibbous phase, again, we see the half of the moon that's closer, that's facing towards us right there. It is mostly lit up with a little sliver of darkness on the left, and that is the waxing gibbous moon. And finally, at the full moon over here, the fully lit side is facing towards us. But the moon is still only half lit up because the far side is unlit over there. And then the moon reverses its phases. So in this case, we can only see this part of the moon right here. It's mostly lit up with a little sliver of darkness on the right. That's the waning gibbous. With the third quarter, we can see the top half of the moon right here. It's half lit up and half dark. With the waning crescent, we can only see this top half of the moon right there. That's the half that's facing towards the earth. It is mostly dark with a little sliver of light, and we come back to the new moon right there with the lit side facing away from us. Okay, so that is the scientific explanation for what causes the phases of the moon right there, which is the moon is always half lit up. It is never more than half lit up. It is never less than half lit up. However, how much of that lit side we can see depends on where the moon is in its orbit around the earth. Now, I think this is a great way to learn the phases of the moon. I don't think it's the best way. I think the best way to learn the phases of the moon is to actually see it for yourself. Build a physical model of the phases of the moon. Now, there are three bodies involved with the phases of the moon. There's the sun, the earth, and the moon. So what you'll need in order to carry this out is you're going to need a light bulb. So I have with me here a light bulb that I'm going to take outside. So it just happens to be a really large light bulb. It's a 300-watt light bulb. So I'm going to take that outside. Obviously, that's going to represent the sun. I have this little styrofoam ball on a stick. That's obviously going to represent the moon. I'm going to hold that out at arm's length, and then I'm going to let it orbit the earth as I hold it out at arm's length like that. So I'm just going to let it come around and orbit the earth like that. So that's going to represent the moon. And then for the earth, you might say, well, he's got that globe behind him. Obviously, he's going to use that for the earth, but I'm not going to use the globe for the earth because it's actually a little confusing to use the globe for the earth, because here's the problem. I'm located in Charlottesville, which is right there on the globe. So in order to see what I'd see in Charlottesville, I'd have to put my eye on the globe like that and then do the phases of the moon like this. And not only that, I'm going to be holding a camera, and that's really hard. So what I'm going to do is something, and in the end, it's obvious in the end, it turns out I carry this big round thing with me wherever I go, and that's my head. What if I just let my head represent the earth? And that makes sense because I live on the earth. My eyes are on the earth. my eyes are on this Earth. So when I build the phases of the moon model, I'm going to use my head to represent the Earth, and my eyes, I'll just use one eye for right now, my eye is the observer standing on the Earth. And the moon, I'm going to hold out there at arm's length like that, and the moon is going to orbit around the Earth. It's going to orbit around my head. So that is the model of the phases of the moon. So I'm going to go outside for a few minutes. I will model the phases of the moon for you. I will be right back outside, and then we'll come back and pick up the lecture after that. So I'll see you outside in a few minutes. All right, here we are outside, and we are building our physical model of the Earth-Moon system to describe why the moon goes through its phases. And the first thing you'll notice is that I've got my three bodies. The bright light bulb representing the sun is over there. This small styrofoam ball on a pole representing the moon is in my left hand. And this camera represents my eyes on the Earth. And so my head represents the Earth, and the camera is right up against my head, which means the camera is on the Earth. In this case right now, you can see that the moon is half lit up, but the lit side is facing away from us. And so, in fact, right now we are experiencing a new moon. Now, as the moon orbits the Earth from seen above, it orbits counterclockwise. And so as I do my phases, when I build this physical model, I will always move to the left. So as I orbit the Earth, as the moon orbits the Earth here, I'm going to move it to the left. So let's go ahead and move a little bit to the left right there. And what do we see? So there's the crescent moon, the waxing crescent moon. First thing you'll notice is that it is lit up on the right-hand side, and you can see that thin little crescent right there over on the right-hand side. As I come along and the moon continues in its orbit around, that is a first quarter moon. Well, right about there, I guess, is a first quarter moon. The moon is half lit up on the right and dark on the left. And then as I come further around, there is the waxing gibbous moon. And I come all the way around over here till we get to the full moon. And then there's an eclipse as it passes into the shadow of the Earth, comes out the other side as a full moon. And then we have the waning gibbous phases going to the third or last quarter moon right there. And then coming back around right there to the waning crescent. Oh, look at that. Isn't that beautiful? Look at that thin crescent moon right there as we come back, and then finally to the new moon again. Okay, so those are the phases of the moon. Now, the most important thing to realize is that when I see the thin crescent moon like this, probably the most common misconception about the thin crescent moon is that it is caused by the shadow of the Earth. But let's look at what's going on right here. My head represents the Earth. Where is the shadow of the Earth right now? Well, look at it. It's back there on that tree way back. Well, it's kind of dark. You can't see it. But there is the shadow of the Earth way back there. The shadow of the Earth is not falling on the moon at all. The moon looks like a crescent because the moon is half lit up, but I can't see most of the side that's lit up because it's facing away from me. And in fact, to answer that learning catalytics question that we did a few minutes ago, why does the moon sometimes look like a crescent? It looks like a crescent because when it looks like a crescent, it is actually closer to the sun than we are. So at this moment, because it is closer to the sun than we are, we can see the unlit side. So let's just step the moon through its phases here for a few minutes one more time. So we start with the new moon, and we come across to the waxing crescent. First quarter, waxing gibbous. Full moon, eclipse, waning gibbous. Last quarter, third quarter, waning crescent, and the new moon again. And just to go through that quickly again, just so you can see the phases of the moon as the moon goes through all of its phases. All right. When we talk about eclipses, we will find out why we do not get an eclipse at every new moon. And I will hint now that it is because the moon's orbit is tilted by about 5 degrees. And you might think that 5 degrees doesn't sound like very much, but remember our scale model of the Earth-Moon system. The Earth should be about the size, well, it should be 1 foot across, and the moon should be about 30 feet away from it. So even a tilt of 5 degrees means that the moon will often pass below the sun or pass above the sun. And when we get over here to a full moon, it will often pass above the shadow. It'll often pass above the shadow of the Earth or pass below the shadow of the Earth, and we won't get an eclipse. So the reason that we do not get eclipses at every new moon and full moon is because of that 5-degree tilt of the moon's orbit around the Earth. All right. Welcome back from making our physical model of the phases of the moon. I hope you enjoyed seeing that. This is something that I think you absolutely have to do. So spend some time wherever you are, whether it's an apartment or at home. Find a ball. Doesn't have to be a styrofoam ball like this. Could be a baseball, a soccer ball, anything that's round like this. You could take a pair of socks and ball them up and make a little ball out of them. Maybe rounder is better than socks, but do the best you can. Find a bright light bulb and model the phases of the moon. If you don't have a bright light bulb handy, you can do it. There's a diagram in your textbook that shows a young woman holding a ball out at arm's length using the sun as the bright light. You can do that as well. But I think you should definitely build this model of the phases of the moon and go through that model. All right. Let's talk a little bit about this physical model. And actually, let's go right to a learning catalytics question, I think. So I want you to think about this. Not only does the moon go through phases as seen from the Earth, but the Earth goes through phases as seen from the moon. If you were standing on the surface of the moon, looking back at the Earth, during the course of the month, sometimes you're seeing the lit side of the Earth, sometimes you're seeing the unlit side of the Earth. The Earth goes through phases. So what I want you to do is answer this question. On June 21st, the moon was new. What was the phase of the Earth as seen from the moon? So go ahead and answer this question. Take about 10 seconds to do it. Or you can pause the video and then come back. All right, what did you get for the answer to this one? If the moon is new, that is, the moon is here in its orbit, and an astronaut is standing on the surface of the moon and they look up at the Earth, what phase do they see the Earth? Well, standing on the moon, looking at the Earth, they see the fully illuminated side of the Earth. They, in fact, see a full Earth. During a new moon, you get a full Earth. During a waxing crescent moon, an astronaut standing on the moon looking up at the Earth would see a waning gibbous Earth. During a full moon, an astronaut standing on the moon would see a new Earth. So it's important to put yourself in the position of the astronaut on the moon and look back at the Earth and think about what side of the Earth they're seeing and how much of the Earth is going to be lit up. In the case of the waning gibbous right here, when the astronaut on the moon looks back at the Earth, they're going to see it lit up on the right-hand side. It's going to be mostly dark right there. And as they come through, the Earth is going to be getting more and more. As they come more to the lit side of the Earth over here, it's going to get more and more lit up. So if it's a waning gibbous moon, an astronaut on the moon would see a waxing crescent Earth. But the Earth goes through phases just like the moon does. All right. Let's do some learning catalytics questions real quick, because I want to think about that observer standing on the Earth and where they see the sun in the sky and where they see the moon up there in the sky. So in this drawing that you see here, where does the sun appear in the sky for this observer? And the hint that I'll give you is, remember that this is noon right here, sunset, midnight, and sunrise. Remember, we've done this a couple times with the Earth rotating, and we said an observer when they're here are at noon. Over here is at sunset, that's midnight, that's sunrise down here. So in that drawing above, where does the sun appear in the sky right now? Take a few seconds to answer this one. And the sun, remember, we're in this one, we're asking about where does the sun appear in this one? All right. I hope you picked the answer A for this one. It appears high overhead. As you can see, for an observer standing here on the Earth, if they're close to the equator, the sun might be directly over the head. Here in Charlottesville, it's not going to be directly overhead, but it will be high in the sky. So it'll be high up, high over our heads, but maybe not directly straight overhead. All right. I want you to answer this question then. In the drawing above, where does the sun appear in the sky for this observer? So now I've moved the observer. Where does the sun appear in the sky? Take 10 seconds to answer the question. Okay. I hope in this case that you saw that in this case, it's around the time of sunset for the observer here. The sun is not high overhead. The sun is in fact on their horizon. So the question is it on their eastern horizon or their western horizon? Well, remember, the Earth rotates as seen from the North Pole here. It rotates counterclockwise. So they are going to the point where they cannot see the sun. Obviously, this is the moment of sunset, and the sun sets over the western horizon. So the sun, in this case, appears right on their western horizon. This is the moment of sunset, so the sun is on their western horizon. Now I want you to answer this question. Where does the moon appear in the sky? So in the drawing above, where does the moon appear in the sky? Not the sun, but the moon. Take 10 seconds to answer this one. All right. So I hope on this one you notice that the moon appears to be high over the observer's head. So the right answer on this one was high overhead. Now, let's put some of these facts together. The time of day here is sunset. The phase of the moon is first quarter, right? You can get first quarter moon from remembering, there it is, remembering this diagram right here. So you've got the observer at sunset. You've got that first quarter moon high over the sky right there. Here's the thing. The first quarter moon is always at its highest in the sky at the moment of sunset. The first quarter moon is always highest in the sky at the time of sunset, because the first quarter moon in its relation to the Earth is right there, and it's going to be at its highest in the sky when the observer is directly underneath it. And so the first quarter moon is always highest at sunset. I want you to answer this question right now. In the drawing above, where does the moon appear in the sky? Where does the moon appear to this observer? So here's the first quarter moon over here. We can eliminate high overhead. It is definitely not high overhead. The sun's high overhead. What time of day is it, by the way? I should have asked a learning catalytics question on this. I didn't, but what time of day is it? Take a few seconds to figure out the time of day for the observer. So hopefully you picked noon, because the observer is at noon right now. So that is noon for the observer. Where's the moon? Well, it's clearly on their horizon, right? If we draw the horizon in for this observer, the horizon is going up and down like this. Is it the eastern or western horizon? Well, the observer is rotating here, which means as the observer comes along 6 hours from now, the moon's going to be high overhead, so the moon must be rising. And if the moon is just rising, it means it's on the eastern horizon. So we have the rising moon on the eastern horizon right there. Okay, here's the important thing. The first quarter moon, it's always highest in the sky at sunset. It always rises. The first quarter moon always rises at noon. It's highest overhead at sunset, and it sets at midnight. And that is true of the first quarter moon no matter what month it is. For your whole life, that's always been true. The first quarter moon has always risen at noon, been high overhead at sunset, and it sets at midnight. Let's go back to this diagram for a second. What about the full moon? The full moon is always highest in the sky at midnight. The full moon is never highest in the sky at sunset or sunrise. The full moon is never visible at noon. The full moon is always highest overhead at midnight. It always rises at sunset, it's always highest at midnight, and it always sets at sunrise. And I told you a bit of a fib earlier, or maybe a lie of omission. I told you that there was this great month this month because the full moon was rising just at the moment of sunset. How often does that happen in your life? Turns out that happens every single month. The full moon always rises at sunset. It doesn't rise at any other time. The full moon never rises at 3 in the afternoon or 1 in the afternoon or 2 o'clock in the morning. The full moon always rises at sunset. It's always highest in the sky at midnight. It always sets at sunrise. The new moon does the same thing that the sun does for the obvious reason that it's in the same direction as the sun. The new moon rises at sunrise, it's high overhead at noon, and it sets at sunset. Let's look at the waxing crescent moon right here, the waxing crescent moon. The waxing crescent moon is always highest at 3 o'clock in the afternoon. It always rises at 9 o'clock in the morning. It's highest at 3 o'clock in the afternoon, and it always sets by 9 o'clock in the evening. That's why the waxing crescent moon is never visible in the middle of the night. It's only visible in the early evening hours and the late afternoon hours. It rises at 9 a.m., it's highest at 3 p.m., and it sets at 9 p.m. The waning gibbous moon. Let's look at the waning gibbous moon. What time does it rise? So I'm not going to tell you this time. I want you to figure it out. What time does the waning gibbous moon rise? Sometimes it's easy to say, what time is it straight overhead? Well, it's straight overhead here. Here's midnight, 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m. So the waning gibbous moon is high overhead at 3 o'clock in the morning. It's always highest at 3 o'clock in the morning. It rises 6 hours before that at about 9 o'clock in the evening, and it's going to set 6 hours after that at 9 o'clock in the morning. Here is a table that shows you the rising and setting times of all the phases of the moon. Now, I'm gonna trick you here a little bit, and I'm gonna say this: I am definitely asking a question on the upcoming quiz about the rising and setting time of the moon. But if you memorize this table, you're not going to be able to answer the question. I want you to be able to figure it out. What you should do is take this table and empty it of numbers. Literally just write it on a piece of paper. Write the phase, when the moon rises, when it transits. Transits means that it's highest in the sky. It literally means it's crossing the meridian, by the way. And then moon set over here. Write the phases of the moon down here and then leave these spaces blank, and I want you to fill them in. But fill them in by looking at this diagram right here. Okay? So fill that table in on your own and then try and reason out what's going on. All right. Answer this learning catalytics question. Around what time does the first quarter moon rise? Okay, I hope you got this one because we actually went over it a minute ago. The first quarter moon rises at noon every day. So the answer is around 12 p.m. All right. To finish here, let me say this. I had said earlier, bring up the slide here, that in the northern hemisphere, we say that the moon is waxing when it is lit up on the right, and it is waning when it is lit up on the left. But here's an interesting thing. In the southern hemisphere, they teach children the opposite thing. In the southern hemisphere, because they are literally hanging upside down compared to us, as they're looking at the moon upside down, it's reversed. To them, the waxing phases are lit up on the left and the waning phases are lit up on the right. Now, the thing is, when the moon is a waxing crescent, it's a waxing crescent to everybody on Earth. Everybody on Earth sees it as a waxing crescent. But when you and I are standing the way we're looking at it, it's lit up on the right. But in Australia, when they're looking at it, and they're looking at it upside down like that, it's lit up on the left-hand side. So, waxing or waning, we often say that it is lit up. Whoops, let me go back to this. We often say that it is lit up on the right or lit up on the left, and I don't like that because it depends on the hemisphere that you're living in. A much better way to say it is the waxing phases are always visible in the evening sky, and the waning phases are always visible in the morning sky, right? Let's go back to this diagram here for a second. The waxing phases are those that are visible in the evening, and the waning phases are visible in the morning sky. So if you go out and you see a waxing crescent, if you see a crescent moon and it is in the evening, you are seeing a waxing crescent. If you go out and see a crescent, but it's in the morning sky, then it's a waning crescent. And that's true regardless of which hemisphere you live in, whether it's the north or the south. Okay? So I'll end this lecture then with this really interesting thought. I hope some of you have had the chance to see the cartoon The Simpsons. I'm sure that all of you have seen at least one episode of The Simpsons. If not, you've really got to get on it. It's one of the greatest cartoon series ever made. But we learn in one of the episodes of The Simpsons an interesting thing about Springfield, where they live. And in that episode, Elon Musk comes over to dinner. And at the end of dinner, which is clearly occurring in the evening because it's dinner time, in the evening, Elon Musk walks to the window and looks outside and sees that. He sees a crescent moon that's lit up on the left side. I will also point out that the horns go a little bit beyond the halfway part, but we won't worry about that. What does that mean about Springfield? Well, because it's the evening sky, it must be a waxing crescent. And because it's lit up on the left-hand side, that means that Springfield is not located in the United States. It must be in the southern hemisphere. Or it could just be that the cartoonists made a mistake and they didn't remember their basic astronomy class that the moon should have been lit up on the other side. If you're interested in reading more about this was first discovered by a good friend of mine, Phil Plait. He calls himself the Bad Astronomer. He wrote a really nice blog about it. The address is down there at the bottom. You can take a look at it. You could just Google it if you want. But I thought it was really funny that Elon Musk steps to the window, sees a crescent moon in the evening sky, but it's lit up on the wrong side for Springfield to be in the northern hemisphere, so Springfield must be in the southern hemisphere. All right, thank you for joining me this lecture. We will pick up in the next lecture with talking about lunar lunacy, some other interesting things about the moon. I will see you in lecture 12. All right, here we are outside, and we are building our physical model of the Earth-Moon system to describe why the moon goes through its phases. And the first thing you'll notice is that I've got my three bodies. The bright light bulb representing the sun is over there. This small styrofoam ball on a pole representing the moon is in my left hand, and this camera represents my eyes on the Earth. And so my head represents the Earth, and the camera is right up against my head, which means the camera is on the Earth. In this case right now, you can see that the moon is half lit up, but the lit side is facing away from us. And so, in fact, right now we are experiencing a new moon. Now, as the moon orbits the Earth from seen above, it orbits counterclockwise. And so as I do my phases, when I build this physical model, I will always move to the left. So as I orbit the Earth, as the moon orbits the Earth here, I'm going to move it to the left. So let's go ahead and move a little bit to the left right there. And what do we see? So there's the crescent moon, the waxing crescent moon. First thing you'll notice is that it is lit up on the right-hand side, and you can see that thin little crescent right there over on the right-hand side. As I come along and the moon continues in its orbit around, that is a first quarter moon. Well, right about there, I guess, is a first quarter moon. The moon is half lit up on the right and dark on the left. And then as I come further around, there is the waxing gibbous moon. And I come all the way around over here till we get to the full moon. And then there's an eclipse as it passes into the shadow of the Earth, comes out the other side as a full moon. And then we have the waning gibbous phases going to the third or last quarter moon right there. And then coming back around right there to the waning crescent. Oh, look at that. Isn't that beautiful? Look at that thin crescent moon right there as we come back, and then finally to the new moon again. Okay, so those are the phases of the moon. Now, the most important thing to realize is that when I see the thin crescent moon like this, probably the most common misconception about the thin crescent moon is that it is caused by the shadow of the Earth. But let's look at what's going on right here. My head represents the Earth. Where is the shadow of the Earth right now? Well, look at it. It's back there on that tree way back. Well, it's kind of dark. You can't see it. But there is the shadow of the Earth way back there. The shadow of the Earth is not falling on the moon at all. The moon looks like a crescent because the moon is half lit up, but I can't see most of the side that's lit up because it's facing away from me. And in fact, to answer that learning catalytics question that we did a few minutes ago, why does the moon sometimes look like a crescent? It looks like a crescent because when it looks like a crescent, it is actually closer to the sun than we are. So at this moment, because it is closer to the sun than we are, we can see the unlit side. So let's just step the moon through its phases here for a few minutes one more time. So we start with the new moon, and we come across to the waxing crescent. First quarter, waxing gibbous. Full moon, eclipse, waning gibbous. Last quarter, third quarter, waning crescent, and the new moon again. And just to go through that quickly again, just so you can see the phases of the moon as the moon goes through all of its phases. All right.
When we talk about eclipses, we will find out why we do not get an eclipse at every new moon, and I will hint now that it is because the moon's orbit is tilted by about 5 degrees. And you might think that 5 degrees doesn't sound like very much, but remember our scale model of the Earth-Moon system. The Earth should be about the size, well, it should be 1 foot across, and the moon should be about 30 feet away from it. So even a tilt of 5 degrees means that the moon will often pass below the sun or pass above the sun. And when we get over here to a full moon, it will often pass above the shadow. It'll often pass above the shadow of the Earth or pass below the shadow of the Earth, and we won't get an eclipse. So the reason that we do not get eclipses at every new moon and full moon is because of that 5 degree tilt of the moon's orbit around the Earth.